Hey everyone. It's been a great conference so far, hasn't it? It's been really friendly. So thanks everyone. Before I start, hands up. Who's seen the movie Groundhog Day? Oh wow, that's loads of people. Hands up if you saw it in a movie theatre. Wow, there's one, okay. This is the next best thing if you didn't get a chance to see it in 1994 when it came out, okay? First of all, I'm going to need you to use your imagination. I'm going to tell you a story in which you're going to be the star. So imagine the scene. So you work for a successful e-commerce company. It's 6 a.m. and your alarm clock wakes you rudely from your peaceful slumber. As you wipe the sleep from your eyes and your dreams crossfade into wakefulness, you remember that today's the big day. It's Black Friday. And the e-commerce company that you work for has got its hopes pinned on making a killing. Now, a couple of hours later, you find yourself at your desk and things are going really well. The orders are piling in and it looks like you're going to meet your targets. Until you notice the first signs of things going wrong. Okay, so customer services are murmuring about some reports of issues in Japan. And before you know it, you're in the midst of a full-scale outage. Now, your incident manager and your instrument team, they spring into action, and within about half an hour's worth of adrenaline-fueled panic, they've managed to get the system back again. So after half an hour of viewing what's gone on here, everything's back again. And you ask yourself the question, what did you learn? Now, fast forward 24 hours. It's 6 a.m. and your alarm clock wakes you rudely from your peaceful slumber. As you wipe the sleep from your eyes and your dreams crossfade into wakefulness, you remember that today is the big day. It's Black Friday. And the e-commerce company that you work for has got its hopes pinned on making a killing. Now, the same thing happens. This time, same incident, different incident commander. Again, you watch. And what did you learn? Okay, so fast forward to the next 24 hours. It's 6 a.m. and you get the picture, okay? Now, for the next 18 days, you experience this same thing, the same scenario, different incident commander. And you're 20 days in and the universe resets. And if you're still of sound mind, you ask yourself, what have you learned about incident response? Okay, so back in the room, that's enough imagination for you. It's all me from now on, so you can just relax, okay? So, Chapter 2, learning how to respond to incidents is hard. So by nature, incidents are unexpected. They're situations of extreme uncertainty and ambiguity. They take place within complex socio-technical systems, otherwise known as organizations, and often the boundary between the human and the technical is somewhat fuzzy. All of this happens under extreme pressure and stress, and you have multiple demands upon you. You have cognitive demands, coordinative demands, communication demands, internal and external. And in 2025, when everything from healthcare to aviation runs on technology and depends on it working, the stakes are high. So learning to be an incident responder is multifaceted and hard. And what's more, you never see the same incident twice. You never see the same incident twice. You certainly never see the same incident 20 times. So even if the incident mechanism is the same, even if the same thing fails, so it's a different day, it's a different time of day, it's different market conditions, different people, different third-party dependencies, and in this day where everyone is doing continuous delivery, the software is changing all the time. And most importantly, if you've seen the same mechanism happen before, people's mental models have changed. So you can never go through that same experience multiple times. So you never see the same incident twice. So when you're done and you're reviewing what's happened, it's not possible to go into a time machine and just go back and try something different. Like you can't A/B test incident response. So it's all a game of shoulda, woulda, coulda. Like, what would have happened if I'd have escalated sooner? What would have happened if I'd delegated better? Should I have raised a SEV 1 rather than a SEV 2? You can never tell. You can never go back and see what would have happened. So each incident is a unique moment in time, shaped by the team's combined experience and decisions. So learning how to respond to incidents is hard. And while you can never experience the same incident twice, there are some ways in which you can get close. So hands up who does game days. I know you do, because you did a really good talk earlier on. Thank you. Tabletop exercises. Anyone else? Hands up. Chaos engineering. Chaos engineering seems popular. Okay, cool. So it is possible to use simulation, or what I call and what nerds in academia call staged world techniques, to create a repeatable scenario and to be able to observe it repeatedly. So what I'd like to describe to you today is an experiment of sorts where 20 incident commanders were given the same incident to respond to, and we as a team got to see the same incident play out 20 times and to understand what we might learn from that. So effectively the facilitators of this experiment were the Bill Murray character in the Groundhog Day. Okay? So what is a staged world? So as I mentioned, there are a few options for kind of repeatedly practicing these scenarios. So we've got tabletop exercises, game days, chaos engineering. Now, staged worlds are a little bit different than that. They're described in the academic literature as somewhere between a really tightly controlled laboratory condition experiment and real-world observation. So in the lab, you'd be wanting to control everything, and we don't want to do that. And we don't want to actually replicate everything that happens in real life because that would be too expensive and too difficult to do. But a stage world is somewhere in the middle where we're trying to create a scenario which has just enough fidelity so that people feel like it's real. So a stage world is a simulated scenario with enough fidelity to feel realistic. And each stage world is designed specifically to elicit expertise. In this case, the expertise we're looking at is in incident response and incident management. Now, importantly, with staged worlds, there is no one solution. So a staged world isn't like a choose-your-own-adventure book, where there's a deterministic branch that you can go down and have several deterministic outcomes. It's a bit more like Dungeons and Dragons. Any dungeon masters in the room? There's no judgment here, Joe. It's okay, you're amongst friends. If you want to learn more about staged worlds, there's a great talk there by Marissa Bigelow, now known as Miss Marissa Grayson at LFI Conf 23. She goes into it in a lot of detail. Really worth watching. So, our staged world, in our case, the staged world that we were running was facilitated on a platform called Uptime Labs. Now, personally, I don't work for Uptime Labs, but I am an advisor, and I help to analyze the data in this experiment. We do have Joe McKevitt in the room, who works for Uptime Labs. Give everyone a wave, Joe. So chat to him later if you want to hear more about what Uptime Labs do. But our stage world involved 20 incident responders with different levels of experience. Some of them have spent many years being incident responders or incident managers. Some of them were reasonably new to it, but definitely they'd all been part of live incidents in the companies that they work for. And they came from 3 different companies. So, as I was mentioning, a stage world needs enough fidelity to be realistic. So in our case, and via Uptime Labs, we have genuine software running on AWS and Kubernetes, which not only mimics, but is an e-commerce website. So any responders, if they log onto the system and they're running commands, they will work as if it's an actual live production system because it actually is a live production system. We have all the observability tools that you might expect, and they respond appropriately based on what is happening with the website. So if you're looking at throughput, response times, and you have an incident or an outage, those observability tools will help you and they will give you signals that you can use in your response. Now, of course, incidents take place in socio-technical systems, so we have to model the social side of it as well, not just the technical side. So we have a whole organizational structure where the individuals in the organization are mimicked by AI-driven bots with a human in the loop to ensure that everything is running fine. And all communication during the incident happens through Slack. As you might expect, real Slack, not simulated Slack, real Slack. Okay. Now, who's had an incident like this before? It's amazing that people actually got this. I didn't think they'd get this. But yeah, like these plates are broken and not broken at the same time. And known as Schrodinger's plates, it's a good kind of metaphor for what we often see. And incidents relatively rarely happen with one thing going on. It's normally a couple of different things that happen that results in something really unexpected. So this metaphor is just saying that in the incident that we were looking at, something happened, but its consequences didn't appear until quite a while later. At the beginning of the incident, a few rings came through from customer services, some issues in Japan. Incident responders come online, incident manager takes control. They notice that the currency service has recently been changed, so they look into that. Eventually, if they get this far, they found that the error is made by some API key changes, but those changes don't actually manifest in terms of the broken plates until the cache is refreshed a couple of hours later. Now, every responder had 25 minutes to resolve this scenario or abandon it. So what did we learn? So we went through this 20 times, and what did we learn? So what happened? I'm sure you're all wondering how many people solved the incident in the time. So 13 out of the 20 responders managed to resolve the incident within 20 minutes. 7 failed. There was no correlation really that we could see between the experience of responders and the time to resolve, though for a single incident you might not expect to see this. Now, it's tempting to think of these 13 who succeeded as being successful and those who failed, but now is a good time to bring up a quote by Dr. Richard Cook, who said that good results come through experience and experience comes through bad results. So, as you were saying earlier on, this is all about learning, and everyone here was a winner, okay? Okay, so what did we notice? Whenever you're looking into incidents, and I'm sure you feel this yourselves, when you're viewing an incident as it's going on, you've got a feeling inside about whether it's going well or whether it's going badly. But if you actually ask yourself, what is it am I noticing that is giving me that feeling? It's relatively difficult to tease it out. And it's nice to have a way of compartmentalizing this. So we used a kind of a model, a framework that was coined in 2021 by our friend and everybody's friend, John Allspar, at SREcon 2021. So he talked about the activities in an incident being separatable into diagnostic activities, therapeutic activities, recruitment, and status and reporting activities. Important to realize that these things don't happen in sequence. It's not we diagnose, then we enter the therapeutic zone, now we go into recruitment. It doesn't work like that. These are just things that happen generally during an incident. So I'll go into each one of these in turn now. So, diagnostic activities. So, incidents are, I like to say, an exercise in multi-threaded attention management. So, these signals are coming at you like a fire hose, and you need to make inferences from those signals. And the signal-to-noise ratio is often really low, and it's your job to determine the salience of each of these signals. So what kind of signals do we have? We have logging, we've got observability, we've got murmurings coming in from customer services, we've maybe got things appearing on social media, we've got what your colleagues are saying, we've also got things that are popping into your head from what you've experienced in the past. You've got these signals that are going, hey, this feels a bit like 2 weeks ago when this thing happened. So that's your case-based reasoning part of your brain coming into action and giving you signals. And we're even getting signals from places that we might not expect. Think back to CrowdStrike. Imagine how many people were looking at a blue screen of death going, what the heck's going on here? And over in the corner of the office, there's BBC News telling them exactly what's going on. So, like, these signals are coming from all over the place. And one of the things that we do with these signals is that we try and determine, one of the first things that we do is we're trying to determine severity. And one of the things that we noticed was, even though this was the same incident and all incident responders had the same instructions on how to determine severity, there was quite a wide disparity on the severity that people assigned to this incident. There were some SEV1s, some SEV2s, some SEV3, some even 4. And interestingly, that severity kind of diagnosis had absolutely no impact whatsoever on the quality of the response. But one thing that we did find, and this is quite interesting, was that some of the people who spent an awful lot of time arguing over what the severity was ran out of time to fix the damn incident. You know, what severity is important, but there are trade-offs, and it's not that important. So another great talk, MROOP, SREcon, there are other conferences apparently. In SREcon, I think it was 24 actually, I think that's wrong. What is severity bit a lie agreed on? Have a look at that talk, it's really cool. Okay, on to therapeutic interventions. Okay, therapeutic activities are the things that you do off the basis of the signals that you found and the diagnosis that you have made. And they're an attempt at either fixing things or finding out more information. I say attempt because it's an educated guess. A lot of the time you don't know what the problem is, and you're just making an educated guess. So examples of this are rolling back changes, restarting services, updating API keys, etc. Now, one thing that we did notice in this experiment was every single participant, apart from one, rolled back the changes, rolled back those currency service changes. And in every single case, it made no difference whatsoever. So the question for you is, were they wrong? Did they make a mistake? Were they wrong to waste time doing something that made no difference? And of course, the answer is no, because there's something magical that happens whenever you make a therapeutic intervention. It immediately becomes diagnostic. You do something that you expect to do something, and it either does the thing that you expected, or it does something different, or it doesn't. And that becomes a signal, which is in turn diagnostic. So just this observation puts pay to the myth that incident response is a linear process where we go from diagnostic to therapeutic interventions to post-incident review. Like most things in life, it's more circular than that. You know who does this a lot? Anyone seen Dr. House? I was watching this a couple of nights ago. He does this all the time. He doesn't know what the heck's going on, and he makes a treatment. He does some wild treatment, and then he learns more information, which improves his diagnosis. And eventually, we all know what happens. Okay, so the next thing, recruitment. This is incident management and response is a team sport. Okay, and we noticed two things, two sort of patterns in our incident responders. The first pattern we named the solo artist, and the second pattern was the band member. The solo artist appeared to take all the responsibility for every single part of the incident upon their own shoulders. And surprise, surprise, they fared less well than the band members. The band members engaged in proper coordination and leveraged the wisdom of their team to help solve the issue. So the solo artist, bit like Taylor Swift or like me wearing this thing, Madonna, right? It's all about them. Whereas the band members, this more in a jazz band, right? They're improvising, but they're trusting each other and they're playing off each other. Yeah, we found that this collaboration pattern was far more successful than people who took everything on their shoulders, and was less stressful as well. A couple of examples here. So we're just seeing some real examples from the experiment here. Someone saying that they want to form an incident investigation team, and someone asking for help. They're just small examples that are clues to people behaving as a band member rather than Taylor Swift. Okay, lastly, status and reporting activities. I like to call this the kind of necessary evil because it has nothing whatsoever to do with fixing the incident? I'll give you two options. Would you prefer a 2-hour outage where the status and reporting was absolutely rubbish, or a 10-minute outage where the stakeholder communication was a car crash? Anyone prefer the 2-hour outage? Don't think so. But these things are still important, right? So, as I say, incident management is an exercise in multi-threaded attention management, and this is one of the things that you need to do. You need to keep your stakeholders updated. Lots of people actually got sidetracked with what we call stakeholder appeasement, which was trying to make their stakeholders, trying to keep them up to date too much at the expense of actually fixing the issue. So everything in incident response is about trade-offs, and some people chose to keep their stakeholders updated rather than fixing the issue. So this is one of the things that we noticed people who did this really well did. They used what we call templating. And so here's an example. This is a template of an incident update that one of the responder did. And you can see that it's really well structured. And it's not an accident. They didn't make this up at the time. They do this all the time. And not only does this contain an awful lot of information, why am I sending this update, where you go to find more details, here's what I know, and here's when my next update is, but using templates like these frees up your cognitive load, so you don't have to worry about what template am I going to be using for my updates. You just do it, and then you can free up the rest of your thinking power to actually fix the incident itself. Okay, so just rounding up these techniques that we observed. So we saw people using muscle memory, just like we saw with that templating thing, to minimize the mental effort associated with this kind of boilerplate stuff, to ensure that they've got more mental capacity to think about the incident itself. They also leveraged the team to coordinate. They spent less time on stakeholder appeasement, and they didn't spend too much time looking at severity. Okay, so 2 minutes left, bit of a roundup. What's next? First of all, some of the limitations of this approach. So we talked about chaos engineering, staged worlds, tabletop exercise, game days, etc. There are some limitations with this approach. So every participant knew that this was an incident. Okay, and that's unusual. You don't go into work in the morning knowing that you're going to get an incident. So that inevitably affects things, okay? Also, in this experiment, the incident commander was alone, and they weren't working with a group of people who they really trusted, and they'd built this kind of common ground of knowledge with and experience with. Also, super important, the stuff that we learned from this experiment, you can't stick it in a bottle and apply it to every incident and expect it to work everywhere, because everything is so context sensitive. But you can use this technique to do this in different scenarios and do it again and again. And that's where you start to build up your database of knowledge that can be applicable across a wide variety of incident scenarios. So what are we looking to do next? So we're looking to do Groundhog Day exercises with teams. In fact, I think we've already done it. We're looking to remove the 20-minute time limit to see how that affects people. And we're also looking to do these experiments with people in different roles. We found that generally people in management positions have a very different picture to what to what happens during an incident compared to practitioners. And allowing people to do this in a safe environment allows them to empathize far more strongly. So we're looking to do that as well. So just one final quote that I'll leave you with. This is from Professor David Woods, who is probably the founder of the resilience engineering world. And he says, resilience is a verb. It isn't what you do, it is what you do. It's not what you have. So resilience isn't robustness. It's not redundancy, failover, or backup. Resilience is what you do when the unexpected happens. And there are things that you can do to prepare yourself for that. And it's really worthwhile considering adding those to your practices in your organization. So I'll leave you with some credits and references, some really great talks there. All good.